Okay, guys, so this lesson is for section 5.2 on factoring. And factoring is one of the easiest ways to try and solve an equation, solve a quadratic equation, but it doesn't always work. So it's a bummer because it doesn't work all the time, but I can look at an expression and know immediately if it can be factored. If not immediately, maybe do a little bit of work. Whereas some of our other solving methods, there's several steps to try to get your solution. So like I said, this is the easiest one to try first. Now, you should have in front of you a factor sheet. It looks something like this. If it doesn't look exactly like mine, it looks very similar to it. And at the very top, it says, how do I factor this expression? Before we start solving with factoring, we just need to learn what factoring is. And you have two options. You either have an expression with 3 terms or with 2 terms. Notice the first 2 bubbles of both of them ask, can you take anything out? And this means, is there anything similar in all 3 terms that could be divided out? It could be a number, it could be a variable. Okay, then let's work down from 3 terms. If I can take anything out, I want to do that. I pull it out front and I show what's left in the parentheses. Okay, if I can't, I move on to that next question, which is in both of these bubbles here, depending on how you work down your flow chart. The second question is, are the first and the third perfect squares? And what I mean by that is you've got 3 terms there. So are the first and the third, that if you take the square root, you'd get a whole number. So remember, we list our perfect squares back when we worked on powers, 1, 4, 9, 36, 25, 64, 81, any of those are perfect squares, okay? If you have the first and the third perfect squares, read the rest of that bubble. It says, and the middle term is 2 times the product of their roots, okay? That's a little bit harder, but it's an easier check piece versus going on and then realizing, oh shoot, it really wasn't a perfect square trinomial, which is what that bubble is called. And I'll show that to you when we actually get an expression in front of us. And then the last question, or the last piece, I guess, is to proceed with general factoring. And general factoring has 2 sets of parentheses. You put the factors of the first term in the first spots in the sets and the factors of the third term in the second parts of the sets. So that's what 3 terms is. First question is, can you take anything out? Second question is, are the first and third perfect squares? Last question is, or last piece is, proceed with general factoring. Over here with 2 terms, I don't have as many options. First thing is still, can you take anything out? But second thing, since there's just 2 terms, it asks, is it a difference of squares? Now this means there's only 2 terms. So that means both of them are square numbers or square terms, all right? And it says it's a difference, so it has to be subtracted. All right, a lot of times you'll see this as a squared minus b squared, something in that form. Okay, if yes, they show you your shortcut pattern. If no, there's nothing else I can do. There is no proceed with general factoring for 2 terms. Okay, all right, so let's just try some of this. Example 1 on page 256 gives me x squared minus 12x minus 28. Okay, so if I look at my factor sheet, how do I factor this expression? There are 1, 2, 3 terms, so I'm going down this side. The first question says, can I take anything out? So do they have anything in common? Remember, there's a 1 here, even if I can't see it right here. Okay, so they don't have any numbers in common besides 1 that could be divided out. They don't all have x's, so an x can't be divided out. So no. Then it says, are the first and the third perfect squares? I stop right there, okay, and I check. Is he a perfect square? Well, yeah, because x is squared, and 1 is a perfect square because the square root of 1 is 1. But then if I look at my third term, 28, 28 is not a perfect square. Okay, remember it goes 1, 4, 9, 16, 25, 36. 28 is not a perfect square. So as I'm going down my thing, no, these are not, the first and third are not perfect squares. I don't even need to check the rest of that bubble. Okay, so now let's go down here. It says proceed with general factoring. I need to make 2 parenthesis sets. Okay. And then it says, using factors of the first and last term that will add up to the middle term. Okay, so if I take a look at this guy, my only option for x squared for factors is x and x, because x times x is x squared. That's the only way I'm going to get x squared. All right? But over here, I've got some other options. Factors of 28 are 1 and 28, 2 and 14, 3 doesn't work, 4 and 7. So it says I have to pick factors that will add or subtract to give me this negative 12. Okay, well, 1 and 28, 1 plus 28 is 29. 1 minus 28 is negative 27. That's not right. That's not even close. 2 plus 14 is 16, and I'm going to cross these guys out. 2 plus 14 is 16. 2 minus 14 is, negative 12. And notice how I used that. It was a positive 2 and a negative 14. Okay, so I'm going to write those in. Positive 2, negative 14. Now, I always do a double check here. Multiply these guys, kind of like when you were, well, have we got to that? Yeah, kind of like when you were multiplying, you were foiling that out. We're going to check the insides and the outsides. Yeah, 2x minus 14x gives me this negative 12x. And then you're going to check the last. Does 2 times negative 14 give me negative 28? Yes, it does. There's my final answer. Okay. All right, so let's work that again. Let's look at number 24 this time. We have x squared plus 9x plus 14. Okay, so I have 3 terms. And my first question is, can I take anything out? Remember, there's a 1 here, even if I can't see it. So 1, 9, and 14, no other numbers can come out. These two have an x, and this guy doesn't, so I can't take a variable out. So the next question is, are the first and the third perfect squares? No, they're not perfect squares. So I go to proceed with general factoring. 2 sets of parentheses. Factors of this guy, the only factors are x and x. Factors of 14 are 1 and 14, and 2 and 7. So I have to pick factors of 14 that will add or subtract to give me 9. 1 plus 14 is 15. 1 minus 14 is negative 13. That doesn't give me 9. 2 plus 7, that gives me 9x. So I want a positive 2 and a positive 7 will give me positive 9. Now let's double check to make sure we're right. This guy gives me 2x. Outside gives me positive 7x. That still gives me my middle. I'm good. Check these guys. A positive 2 times a positive 7 still multiplies to give me 14. This is my final answer. This stuff is just your check down below. Okay? All right. Let's check. Let's do one more. Let's try number 29. (29) is a squared plus 3a minus 10. Okay, first question. There's 3 terms. Can I take anything out? Remember, there's a 1 in front here, so I'm talking about 1, 3, and negative 10. No, they have nothing in common. These guys have variables and this guy does not. So I can't take anything out because remember, you have to be able to take it out of all 3 terms. So the next question is, are the first and the third perfect squares? Well, this guy is, but 10 is not. So that bubble is not going to work. So we go down to proceed with general factoring. 2 sets of parentheses. A squared will just split into a and a. Factors of 10, 1 and 10, 2 and 5. Remember, I need to pick factors of 10 that will add or subtract to give me 3. Well, 1 plus 10 is 11. 1 minus 10 is negative 9, so that doesn't work. 2 plus 5 is 7. 2 minus 5, though, is negative 3. So I'm close, it's just that my signs are wrong. But let's think about that in the other order. I did 2 minus 5. Excuse me, what if I do 5 minus 2? That gives me a positive 3, meaning I made the 5 positive and the 2 negative. And it doesn't matter what order you put them in. I could have put a minus 2 and a plus 5. That's still okay, because if I check, this gives me 5a. This gives me negative 2a. Yes, that gives me 3a like I wanted. And then if you check your last terms, is a positive 5 times a negative 2 still negative 10? Yes, it is. There's my final answer. Okay. All right, so notice all 3 of these, I couldn't take anything out. The first and thirds were not perfect squares, but I could general factor all 3 of them. Okay, so that's example 1. Now let's take a look at example 2. Okay, example 2 gives me (3x² minus 17x plus 10. I still have 3 terms, 1, 2, 3. All right, so first question is still, can I take anything out? Now, I finally have something besides a 1 out front, but still, 3, 17, and 10, I can't divide anything out of all of those equally. And these guys have x's, but this one does not, so I can't take anything out. Next question is, are the first and the third perfect squares? 3 is not a perfect square. Even though this guy is, 3 is not. They both would have to be. And 10 is not a perfect square either, okay? So I can skip that bubble, and I go right to proceed with general factoring. Now I need to work a little harder out front here, because I need, instead of just saying, oh, this is going to split to x and x, I have to deal with that 3 as well. So I know factors of 3 are 3 and 1. And factors of 10 are 1 and 10 and 2 and 5. Okay? If I have a choice, I throw in the ones that I know don't have an option, meaning I have no other option here except 3 and 1 for 3. He only has one set of factors. So I go ahead and put him in 3x and 1x. 3x times x is 3x squared. Okay? So he's my only option there. Granted, I could have changed their order. I could have put x here and 3x here, but the numbers aren't going to change. Now I have to work a little harder over here, because I have to choose factors, remember, that will add or subtract to give me negative 17. But now they also have to work with this 3 and this 1. Okay, so sometimes this takes a little guessing and testing. So let's throw 1 and 10 in here. Now if I do my check, this is going to give me 1x and 30x. Now, if you add or subtract those, are you going to get negative 17? No, because 1x plus 30x would give me 31x, and 1x minus 30x would give me negative 29. Not even close. Now, before I rule 1 and 10 out, let's change their order. So now, the middles give me 10x, and the outsides give me 3x. Can I get negative 17 now? No, because 10 plus 3 is 13, and 10 minus 3 is 7. Neither one are 17. Now I can say I've tried 1 and 10. In both orders, neither one works. So let's try 2 and 5 now. Okay, check your middles. 2x. Check your outsides. 15x. Can I get to negative 17? 2 plus 15 is 17. What would my signs need to be to get negative 17? They would both need to be negative. Negative 2 minus 15, same signs, would give me negative 17x. So that means both of these guys have to be negative. But let's do our final check. Do I still get a positive 10 when I multiply negative 2 times negative 5? Yes, I do. That gives me a positive 10, just like I was supposed to get here. Here is my final answer. Okay, so let's do this on number 42. Number 42 says, 11m squared plus 14m minus 16. 3 terms, 1, 2, 3. First question, can I take anything out? 11, 14, and 16? No, there's nothing I can take out there. These guys have variables, and this one does not, so I can't take any, I couldn't take any numbers out, I'm sorry, and I can't take any variables out. Are the first and the third perfect squares? 11 is not a perfect square. 16 is, but he has to work as well, so that bubble's not going to work. So I go to proceed with general factoring. 2 sets of parentheses. Factors of this guy, well, factors of my 11 are 1 and 11. I only have that one option, so I might as well go and write them in. 1m and 11m. But when I move over to 16, I've got some more. 1 and 16, 2 and 8, 4 and 4. I have to decide which one of those I'm going to pick. Now, you guys can pick in any order, and you don't always have to try all of them. If you think you know by just looking which one is going to work, try him first. You don't have to start with 1 and 16, meaning I think 16 and 1 is going to be way too big. So I'm going to skip him, and if I have to come back and use him, that's fine. But I'm going to try 2 and 8, all right? So let's try 2 here and 8 here. Remember, I could have done it in the other order. I could have put 8 here and 2. But think about that. If I put 8 here, that's matching him up with 11. 8 times 11 would have been 88. That's way bigger than 14. All right, so I'm going to try my 2 here. That gives me 22m and 8m. 22 plus 8 is 30, but 22 minus 8 gives me 14. It gives me 14 when 22 is positive and 8 is negative. So that means, how did I get that 22? I got it from my insides. So my inside needs to be positive, and my outside needs to be the negative. Now let's double check and make sure we get negative 16. 2 times negative 8, does that give me negative 16? Yes, it does. There's my final. Okay, and that way I didn't even have to try all of those. Granted, I was lucky. I just happened to pick 2 and 8. But I'm saying if you think 1 is too big, don't try it. Wait till the end and try him last. Okay, let's try number 45. 45 is 12v squared minus 25v minus 7. Okay, 3 terms, 1, 2, 3. Can I take anything out? 12, 25, and 7, no, they have nothing in common. These guys have v's and this does not, so I can't take anything out there. Are the first and the third perfect squares? No, neither one is a perfect square. So I'm going to general factor. Factors of 12. Now I have some choices out front. I could have 1 and 12, 2 and 6, 3 and 4. Over here at 7, I only have 1 and 7, so we might as well throw him in. 1 and 7. I only have one option, so put him in there. And remember, you could have done, excuse me for a second, you could have done 7 and 1 instead of 1 and 7. It doesn't matter there. So now I have to pick factors of 12 that will work together with this 1 and 7 to give me a negative 25. I'm going to skip over this 1 and 12, all right? And I'm going to start with 2 and 6. If I need to come back to him, I will. So I'm going to try 2v and 6v. All right, check my middles. That gives me 6v. Check my outsides. That gives me 14v. 6 plus 14 would give me 20. I need negative 25. 6 minus 14v would give me negative 8. That's not what I needed. Okay, so that's not going to work. Let's change their order. Let's put the 6 here and the 2 here. Now, let's think about this. If I put the 6 here, that pairs him up with the 7. 6 times 7 is 42. This middle is only 2. There's no way I'm getting back to negative 25. So that order is not going to work. Okay, 6 and 2 has been tried. They're not going to work. Okay, all right. So I'm going to try 3 and 4. 3v, 4v. The middle gives me 4v. Outside gives me 21v. 4 plus 21, yes, that gives me 25, but I need a negative 25. So that means both of these guys would have to be negative. That means my inside has to be negative and my outside has to be negative. Negative 4v, negative 21v would give me negative 25. Then let's check the outside. Negative 1 times negative 7. Wait a second. Negative 1 times negative 7, that doesn't give me a negative 7. 2 negatives should give me a positive. So that doesn't work. That's why it's so important to check both. All right. Yes, the middles and the outers worked, but when I checked those last terms, that doesn't work. So that pattern, that order is not going to work with 3 out front. Let's switch them. Let's do 4v here and 3v here. Get rid of those signs because we got to start that again. Check your middle. 3v. Your outers, 28v. 3 plus 28 would give me 31. That doesn't work. 3 minus 28, that gives me negative 25. The 3 would have to be positive. The 28 would have to be negative. 3 minus 28 gives me negative 25. So now the 3 is positive. The 28 is negative. And does my final check work? Is positive 1 times negative 7 a negative 7? Yes, it is. That's why it is so important to check both, guys. Okay, if I just would have checked my middles right here, I would have said, oh, great, I found one. I'm done. But that last way we tried did not work. Okay, so you've got to make sure you check those last ones. So those are all examples of example 2, where you have to work a little harder with general factoring. Okay, let's take a look at example 3. Sorry about that. That was interesting. Okay. All right, example 3 gives me 4x squared minus 25. Now, we only have 2 terms here, so we're looking at a different side of our flow chart now. 2 terms, the first question is, can I take anything out? Well, you've got 4 and 25 for numbers. No, you couldn't take anything out of those, and neither one, or I mean, this guy has x's, but this guy does not, so you couldn't take any variables out. So, can you take anything out? No, we could not. So then it says, is it a difference of squares? Remember, that means that it is a subtraction problem. Well, ours is. And then it means, are they both perfect squares? Well, 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So yes, it is. And it shows us that the pattern should be a plus b, a minus b. Okay? But what do those a and b's mean? Well, they are your roots, meaning 4 and 25, yes, they're perfect squares, but what are their roots? They come from 2x and 5. So meaning the square root of 4 is 2, the square root of x squared is x, and the square root of 25 is 5. So this is my a, and this is my b. Now all I have to do is sub them in. 2x plus 5 and 2x minus 5. And I'm done. Remember, there's no other bubbles down here. There is no proceed with general factoring or anything like that. So 2 terms should be quick. Let's try another one. Example 3b gives me 9y squared plus 24y plus 16. Now, I'm back to 3 terms here, guys. All right, so remember our first question is, can I take anything out? No, I cannot take anything out of 9, 24, and 16. They don't all have y's, so I can't take variables out. So the next question, are the first and the third perfect squares? Yes, they are. Square root of 9 is 3. Square root of y squared, of course, is y. And the square root of 16 is 4. 3 squared is 9. 4 squared is 16. So then we have to read the rest of that bubble. Remember, the rest of that bubble says, and the middle term is 2 times the product of their roots. Well, what's 3 times 4? Their product, 3 times 4 would be 12. And if you took that times 2, like that bubble says, 12 times 2, yes, that gives me 24y. So then if you take a look over here, remember we couldn't take anything out, so we came over here. Yes, the first and third are perfect squares, and the middle is 2 times their product, so we're going here. It says, if the signs are positive, positive, use a plus b squared. If the signs are negative, positive, use a minus b squared. Well, ours are positive, positive, so we're going to use a plus b quantity squared. What's our a and our b? A is here, b is here, so we have 3y plus 4 quantity squared. There's my final answer. I didn't circle him up here, but there's my final answer there. That's an example of a perfect square trinomial. Okay, that's his special name. This guy is called a difference of squares. This guy is called a perfect square trinomial. Trinomial meaning 3 terms that has perfect squares for the first and third terms. All right, let's look at C. C gives me 49r squared minus 14r plus 1. First question, can I take anything out? No, especially since you just have a 1 here. There's no number you're going to be able to take out, and they don't all have r's. So are the first and the third perfect squares? Yes, they are. The square root of this would be 7r, and the square root of 1 is 1. Now read the rest of that bubble. Is their product times 2 your middle term? And you can ignore the sign. 7r times 1 is 7r. That's their product. Then it says we have to take it times 2. 7r times 2, yeah, that gives me 14r. Take a look at their signs. It's a minus plus, so that means we have to follow this pattern, which in our case would be 7r minus 1 quantity squared. That's also a perfect square trinomial. Okay? So whereas up here with a difference of squares, you only had one option, a plus b, a minus b, that's your factor pattern. When you're looking at perfect square trinomials, you have to pay attention to signs. It's either going to be a plus b quantity squared or a minus b quantity squared. And you look at their signs to decide that. Plus plus is this pattern, minus plus gives you this pattern. You will never have a plus minus if it's a perfect square trinomial. Okay, so let's practice some of those from the homework. Take a look at number 53. '53 gives me 49 minus 100a squared. I picked this because we're used to seeing the variable first, and as you can tell, this one has the variable second. It's okay, it's still 2 terms. So the first question is, can I take anything out? 49 and 100, no, there's no number I can take out of those. And this guy doesn't have any a's, so I can't take any variables out. Next question, is it a difference of squares? Yes, it's a difference because I have subtraction. Are these square numbers? Yes, they are. This would be 7, and this would be 10a. 7 squared is 49, 10 squared is 100. So my pattern is a plus b, a minus b, or in our case, our a is 7 and our b is 10a. Don't get freaked out because these are a squareds and they want a. That's just, you can think of him as x if you don't like that variable. All right, so this would be 7 plus 10a and 7 minus 10a. Remember, this could be written the other way around. It could be 7 minus 10a and 7 plus 10a. That's fine. And a lot of times I think I usually do a plus b, a minus b, but if you don't, you like it the other order, that's fine too. It's not going to be any different. Okay, but I couldn't say 10a plus 7 and 10a minus 7. That 7 has to be in the first spots. Okay, so that's another example of difference of squares. Let's do another example of a perfect square trinomial. Let's look at number 54. 54 says 25b squared, and I'm going to change that to x because I don't like the variable b. Mine always look like 6's. Minus 60x plus 36. Back to three terms here. 1, 2, 3. Can I take anything out? 25, 60, and 36? No. And they don't all have x's, so I can't take anything out there. Are the first and the third perfect squares? Yes, they are. This would be 5x, and this would be 6. But remember, the rest of that bubble says, is their product times 2 your middle term? Well, 6 times 5 is 30. If I take that times 2, yeah, that gives me my middle term. Remember, the sign doesn't matter when you do that. All right. Then I think, yes, this is a perfect square trinomial. Is it plus plus or is it minus plus? It's minus plus, so that means I use a minus b quantity squared, or in our case, 5x minus 6 quantity squared. There's my answer. Okay. All right, last example, guys. We're almost there. Take a look at example 4. Example 4. Example 4 is going to try and pull everything together because we've got one question we haven't used yet. So for example 4, we have 5x squared minus 20. You've got two terms here. First question is, can I take anything out? Can I take anything out of 5 and 20? Yeah, I could take 5 out. Can I take any x's out? No, because this guy doesn't have any x's. So that bubble says, pull the common term, that 5 that could be taken out, pull him out front, and then tell me what's left. And remember, you're dividing, meaning 5x squared divided by 5 would be x squared. 20 divided by 5, or negative 20 for that matter, negative 20 divided by 5 is negative 4. Now, we're over here on our factor sheet, two terms. Can we take anything out? Yes, we could. We're not done here. Look, there's a line that comes down from it. Is it a difference of squares? Meaning, when you look inside this parenthesis, do you have two terms that are squares with a subtraction sign in the middle? Yes, you do. This guy's root would be x. This guy's root would be 2. So remember, this difference of squares pattern is a plus b, a minus b. Or in our case, x plus 2, x minus 2. What about this 5? He just gets to keep being brought down in front. There's my final answer. Okay, so yes, you answered that first term or first question, but you're not done there. You have to go through the rest of the questions. Let's take a look at part B. Part B says 6p squared plus 15p plus 9. Three terms this time. 1, 2, 3. Can I take anything out? Can I take anything out of 6, 15, and 9? Yes, I could take a 3 out. Can I take any p's out? No, because this guy doesn't have any p. So the 3 goes out front. Now, what's left goes inside the parentheses. So 6 divided by 3 would be 2p squared. 15 divided by 3 would be positive 5p. And 9 divided by 3 would be 3. Now we look at what's left in parentheses, and we still ask ourselves that next question. Are the first and the third perfect squares? No, neither one is. So then we have to try to proceed with general factoring. Two sets of parentheses. Notice I brought that 3 down in front. He just has to keep carrying down. Factors of 2p squared. I only have 2p and 1p. All right, factors of 3. Again, I only have one set of factors, 1 and 3. Now, they could be in a different order. all right? But I might as well go ahead and throw them in and see which one works. I'm trying to get 5, 1p, and 6p. Well, 1 plus 6 is 7. That doesn't work. 1 minus 6 is negative 5. Okay, I'm close. I just need a different sign. If I make this negative 1 and positive 6, negative 1 plus 6 would give me a positive 5. So this guy would need to be negative, and the 6 would need to be positive. Check your final check, though. Is negative 1 times positive 3 a positive 3? No, a negative and a positive does not give me a positive, so that order does not work. We better change it. Let's make the 3 here and the 1 here. This gives me 3p. This gives me 2p. 3 plus 2 would give me 5 if both of those are positive. And if you do your final check, positive 3 times a positive 1, now that gives me a positive 3. This whole thing is my final answer. All right, so again, we had to work a little harder on that one. We had to work a little harder. Okay. All right, I'm going to run out of room, so I got to do... This time we're on C. Example 4C is 2u squared plus 8u. 2 terms this time. Can you take anything out? Can I take anything out of 2 and 8? Yeah, I could divide 2 out. These both have u's. This guy has u squared, and this guy has 1u, or u to the first. So I could take a u out. They both have at least 1 u. What's left? Well, 2 divided by 2 is 1. U squared divided by u, remember your power rules, divide by subtracting, there would be 1u left. 8 divided by 2 is a positive 4. U divided by u, remember subtract those, there would be no u's left. Remember, we're not done. Look inside the parentheses. Do you have a difference of squares? For 1, you do not have a difference. You have a sum. And this guy is not a square term, so I'm done. That's all you can do. Did I factor this? Yes, I factored it because I took something out. Just because I didn't have 4 steps or whatever the case may be does not mean you didn't factor it. All right, by taking something out, that's still factoring. So he was easy. Let's take a look at D. We have 4x squared plus 4x minus 4. 3 terms this time. Can I take anything out? Obviously, they all have 4's, but they do not all have x's, so we can't take a variable out. When I divide 4 out, 4 divided by 4 would just leave me with x squared. 4x divided by 4 would leave me with x. This is where I see the most people mess up. 4 divided by 4, oh, well, I took 4 out, so it's gone. No, remember you're dividing. 4 divided by 4 would be a negative 1. If you start out with 3 terms, you have to have 3 terms after you took something out. Now, next question, are the first and the third perfect squares? Yes, they are. This guy would be x, and this guy would be 1. But remember the rest of that bubble. Their product times 2 has to give me my middle term. X times 1 is x, but when I take it times 2, that's 2x. That's not my middle term, so this is not a perfect square trinomial. So now let's try to general factor. Factors of x squared, x and x. Factors of 1, 1 and 1. There can be no other order, because if you switched them, it would still be 1 and 1. Let's do our check. 1x and 1x, you're trying to get to 1x. Yes, that should sound funny to you. 1 plus 1 is 2. 1 minus 1 is 0. So you'd never get to just 1x. So that means this does not work because remember, you can't change their order and you have no other factors to work with. This is my final answer. Did I factor it? Yes, you factored it because you took a 4 out. It's just I couldn't go any farther than that, and that's okay. Okay, so that's using your whole factor sheet there, using your whole factor sheet. Let's try 2 more here, guys, 2 more. We're going to look at number 59 and number 63. And I'm almost done. You guys are doing great. Number 59, well, I assume you are, in my imaginary video world. 59 is 8y squared minus 28y minus 60. I've got 3 terms. Can I take anything out of 8, 28, and 60? I could definitely take 2 out, but I could take 4 out as well. I want to take the biggest number out. They don't all have y's, so I can't take any y's out. That would give me 2y squared. 8 divided by 4 is 2. 28 divided by 4 is 7y. And 60 divided by 4 is 15. And I always double check. 2, 7, and 15. No, there's nothing else I could take out. So I know that 4 was the biggest term. Okay, are the first and the third perfect squares? No, 2 and 15, neither one is. So now I'm ready to try general factoring. My only factors of 2 are 2y and y. Factors of 15, though, I've got 1 and 15 and 3 and 5. I'm going to try to leave 1 and 15 there. I'm going to try them last since he's the bigger one. Let's try 3 and 5 here. This would give me 3y. This would give me 10y. If I add them, I get 13. 3 minus 10, though, is negative 7. That means the 3 needs to be positive, and the 10, 2y times 5, needs to be negative. 3 minus 10, yes, that gives me negative 7. Now do your final check. Positive 3 times negative 5, does that give me a negative 15? Yes, it does. There's my final answer. Okay, last one, number 63. 63 says negative v squared plus 2v minus 1. Sorry, that's looked like an R. Can you take anything out of all 3 terms? This would be a negative 1, 2, and a negative 1. Technically, no. You're thinking, no, there's nothing I can take out besides 1, but here's my deal with this. I never want to factor when it starts with a negative. Okay, so I want to start with a positive number every time, meaning if I take a negative 1 out, then I have a positive v squared, a negative 2v, and a positive 1. This is much easier to try and factor than if I start with a negative term. So I would always factor a negative out if it starts with a negative. Okay, now, are the first and the third perfect squares? Yes, they are. This guy is v, this guy is 1, and is their product times 2 the middle term? V times 1 is v, times 2 would be 2v. Yes, that works. So remember, then I'm looking at these signs and asking myself, do I have a plus plus or a minus plus? I have a minus plus, so my bubble says I need a minus b quantity squared, or in our case, v minus 1 quantity squared, and that negative 1 is out front. Okay, all right, so that should get you through this first homework section, which is 24 through 64 even, okay? I want you to pay attention to the headings in your book, guys. If you notice, that first section just says factoring x squared plus bx plus c, meaning very basic general factoring here. I still want you to use your factor sheet, but I want you to just pay attention to that. Second one, still factoring, but it's taking that general factoring to the next step. It's making us work a little harder. Up at the top of the page, factoring with special patterns. Special patterns means difference of squares or perfect square trinomial. Okay, so you should be looking for that, thinking I should probably have that in this section. Next one, factoring a monomial. What does mono mean? It means one, meaning I can take something out before I do anything else. Okay, so make sure you're paying attention to that. And that's as far as you guys go. Please make sure you're using your factor sheet the whole time. Good luck.